Yeah, so you're trying to hydrogen bond these two compounds together. Yeah, but not water. This compound and that compound. So when you draw this guy out, you know what your donors and your acceptors are. Now look over here. This is an acceptor. He's going to have to pair with the donor. You could pair him with that hydrogen or that hydrogen. And draw it. No, it's similar to what we did in that. Hang on, we gotta get a Dr. Numbers. Hang on.
Sorry about that.
Sorry. No, we got it. Just-
You're good.
Okay, here we go.
I can do a lot of things around you.
I understand, me too. I'm like, okay.
I forgot something in my office. I will be right back.
Oh.
Okay, folks. I'm going to start with a couple of announcements. Number one is that today is the W deadline if any of you need to withdraw from any course. Number two is that I forgot to post Monday's homework, so you got 5 points. Now, that being said, I will say this about that homework and stuff, or about the, about the homework. There's been multiple times I've done such, which means probably roughly about 4% of your grades already been curved. So I won't be covering grades at the end of the semester, so keep that in mind. The next thing I wanted to mention is that I noticed today when I was going through it that several of you are not doing the chemistry math tutorials, which it lists out on Blackboard that are due. And I noticed several people got zeros for like 4 of them, and I'm only dropping 2. So you may want to do the rest of them, 3 of which are due on Sunday. All you got to do is go in this week's folder, find the chemistry math ed puzzle folder, and click on each link and it'll take you to the appropriate document. So there's several, and there is a homework. I've already made the homework. It's only 5 questions that are going to be due on tomorrow night. So there is a homework that's due tomorrow night. So just letting you know a few things. Also, I just wanted to mention that I will be next week hosting class, but it will be on Zoom only. We will not be meeting in person. When the folders link goes live this coming Friday, you will see the link for the Zoom. And all you will have to do is click on the link and it'll take you to class during our regularly scheduled class time. And then my office hour on Tuesday is also going to be via Zoom rather than in person. So I won't be on campus next week. So, any questions? Okay, so we started the semester talking about the atoms of the elements, which are found on the periodic table. Each atom of an element contains protons, neutrons, and electrons. And those protons, neutrons, and electrons have mass. When you add up the mass of the protons plus the mass of the neutrons plus the mass of the electrons, you get the mass of the atom. We then talked about how within a element, there are different isotopes. And so the average atomic mass, which you find on the periodic table, is the result of taking into account all naturally occurring isotopes and their abundances. So we spent time discussing the atoms of the element. We then started combining those atoms of the elements to form compounds, and we talked about ionic compounds, and we talked about covalent molecules. Specifically, we started learning how to name ionic compounds and covalent molecules. And then we moved into some of the mathematics, where we talked about how to convert between mass and moles, and how to convert between atoms and moles, and how to convert between molecules and moles, and how to convert between a variety of other things. But it was still all about the atoms of the elements and all about the molecules. Today is the first day where we start talking about chemical reactions. A chemical reaction is illustrated using a balanced chemical equation. A balanced chemical equation first of all is written where you have the reactants on the left-hand side, an arrow, and then the products on the right-hand side. The reactants are the substances added into the reaction. The products are the substances obtained from the reaction. The arrow notation means yields, produces, or in the case of balancing a chemical equation, it means equals. Now, reactions must be balanced to follow the law of mass conservation. Which states that matter cannot be created nor destroyed. Specifically, we're talking about its mass can't be created nor destroyed. So let's think about this. Back at the beginning, we said atoms have mass. We said that their mass was made up of the protons, neutrons, and electrons within those atoms. That mass can be described using the average atomic mass found on the periodic table, where that average atomic mass is associated with all naturally occurring isotopes of the elements. Each atom has its own mass. That's why when we were making the formulas and determining the molar masses of the compounds, we had to add up the mass of every element in that compound is to follow the law of mass conservation. We have to do the same thing with a balanced chemical equation because mass can't be created nor can it be destroyed. So in other words, if you have an atom of an element on the reactant side, you have to have equal quantities of that atom of the element on the product side. So let's talk about the process. And I use RXN as reaction. That's just my shorthand notation, RXN. It's actually a common shorthand notation for reaction. Step number 1 is to start with the unbalanced reaction. Probably in this particular class, that's not going to be an issue, but as you move forward, it could be. You always start the balancing act with an unbalanced reaction. The second thing you should do is you should look at the reactants and the products to identify commonalities. Especially polyatomic ions. Then you're going to make a list of the atoms found on each side of the equation. And here's where those polyatomics come in handy. If a polyatomic ion exists on the reactant side, and that same polyatomic ion exists on the product side, then list the polyatomic as a unit. Fourth, you're going to note how many of each element is on the reactant side and the product side. You will then multiply substances by a coefficient so as to obtain equivalent amounts of each element on the two sides of the equation. Do not change the formula. You're only allowed to change the coefficients. Finally, when all elements are balanced, make sure the coefficients are in the smallest whole number ratio possible. Now we're going to look at some examples. And that's all we're going to do today and Friday. Okay, I'm starting with the unbalanced equation. The reason I know it is because there's no coefficients. Now I'm just going to take a moment and look at the equation. I notice I got carbon, I notice I got sulfur, but I don't have any polyatomics. I just have carbon and sulfur. So I'm going to make a list of the elements I have. I have carbon. And I have sulfur. And I usually think of this arrow again as an equal sign. On the left-hand side of that arrow, I have one carbon because there's just one C showing. And I have 8 sulfurs because there's the subscript of 8. On the product side, I have one carbon showing. And I have 2 sulfurs showing. This is not balanced because in order for it to be balanced, the number of you've got to have equivalent numbers of each element on the 2 sides of the equation. So it's not balanced because my sulfurs are not balanced. To make the 2 sulfurs balanced, I need to multiply the right-hand side through by 4. Because when I multiply by 4, I get a total of 8. Whatever you multiply by becomes the coefficient. But let's talk about what that form means. What that form means is that it means I have CS2 4 times. So yes, I did get 8 sulfurs. But I also wound up with 4 carbons. The 2 sides are not balanced because on the left side I have 1 carbon, on the right side I have 4 carbon. To make the 2 sides balanced, I need to multiply the left-hand side through by 4 to give me a total of 4 carbon. Whatever you multiply by becomes the coefficient for that substance. And this is the balanced chemical equation for the reaction of carbon with sulfur or S8 to form carbon disulfide. Let's look at another one. Let's do the reaction of sodium with oxygen to form sodium oxide. I take a moment, I look at this reaction and I see I have sodium and I have oxygen. But I don't have any polyatomics. So I'm going to list out the sodium. I'm going to list out the oxygen. Oops, that's not supposed to be an O2. That was supposed to be sodium oxide, not sodium peroxide. On the left-hand side, I have 1 sodium. And I have 2 oxygens. On the right-hand side, I have 2 sodium and I have but 1 oxygen. Where do you want me to start balancing? It does, why I asked that question is it really doesn't matter where you start balancing. This is kind of like piecing out a puzzle. Sometimes you're gonna pick up a puzzle piece and you're gonna get it right on the first try. Sometimes you're gonna have to erase and start over. It's a back and forth. There's no pure way to do this. I'm gonna start with the oxygen this time. On the left-hand side, I have 2 oxygens. On the right-hand side, I have 1. I'm gonna multiply the right-hand side through by 2 in order to get 2 oxygens. Whatever you multiply by becomes the coefficient. But that means that 2 oxygens, or that 2 out in front, means I have 2 Na2Os. So yes, I did get out my 2 oxygens. But I also wound up with 4 sodiums. So now I'm going to try to balance the sodium. On the left-hand side, I have 1. On the right-hand side, I have 4. To make the 2 sides balance, I got to multiply the sodium by 4. Whatever I multiply by becomes the coefficient. And that is the balanced chemical equation for the formation of sodium oxide from its elements, sodium and oxygen. Let's look at another example. Let's go with aluminum nitrate plus sodium carbonate goes to make aluminum carbonate plus sodium nitrate. This is where that second step becomes particularly useful. I'm going to take a moment and just look at my equation. And when I look at my equation, I see I have nitrate on the reactant side, but I also have nitrate on the product side. I have carbonate on the reactant side, but I also have carbonate on the product side. When that occurs, it's going to make your life a lot easier if when you're making your list, you keep that polyatomic as a unit. On the reactant side, I have 1 aluminum, I have 2 nitrates, I have 2 sodium, and I have 1 carbonate. On the product side, I have 2 aluminum, I have 3 carbonates, I have 1 sodium, and I have 1 nitrate. and I made a mistake. That should have been a 3. So I have 3 nitrates. Okay. It doesn't matter where you start balancing. I'm going to start with the aluminum. On the reactant side, I have 1 aluminum. On the product side, I have 2. In order to make the 2 sides equal, I have to multiply the reactant side by 2. But that 2 means that I have 2 AlNO3 threes. So how many nitrates do I have? I have 6 of them. So I'm going to go with the nitrate next. On the reactant side, I have 6. On the product side, I have 1. To make the 2 sides equal, I've got to multiply the product side through by 6. Whatever you multiply by becomes the coefficient. But that means in getting my 6 nitrates, from 6 sodium nitrates, I also wound up with what? 6 sodiums. So working on the sodium, on the reactant side, I have 2. On the product side, I have 6. In order to make the 2 sides equal, I got to multiply the reactant side through by 3. Whatever I multiply by becomes the coefficient. So it gave me 6 sodiums, but what else did it give me? 3 carbonates. And that is the balanced chemical equation. Now, folks, you don't have to write out. First of all, I've been writing out these so that you could see them. But technically, you can go, okay, I've got 2 times 1, which is 2. I have 2 times 3, which is 6. So you don't have to write it out. I have 3 times 2, which is 6. I have 3 times 1, which is 3. But you can write it out if that helps you to see it. It's up to you which works better for you. Let's look at another example. We're going to go with ammonium chloride plus Pb3PO42 going to make NH4 3PO4 plus PbCl2. I want to give you a moment to try it. How did it go? It's a bit more challenging and it takes practice. In this one, I started with the lead. If I'd have started with the ammonium or the chlorine, I would have been going back and forth. why I did this one and why I wanted you to do it. If you start out with the ammonium, for instance, and you see that it's not gonna work, go to the next one, or erase everything, go to the next one and start with it. If you see that going with the chlorine is not making it easy, erase everything and start with the lead. That will help you if you'll just start from scratch, because if you keep trying to go back and forth, sometimes you're going to get lost in the minutia and you're going to go, I don't know where I'm at anymore. Whereas if you'll go back and start from scratch, it will play out okay. So I started with the lead to make sure that the leads were the same. There were 3 leads on the reactant side. So I multiplied the product side by 3 to get 3 leads. When I did so, though, I wound up with 6 chlorines. So I multiplied the reactant side through by 6. Whatever I multiplied by became the coefficient. But in doing so, I wound up not only with 6 chlorines, but also 6 ammoniums. To make the 2 sides equal on ammonium, I multiplied the product side through by 2 in order to get 6. And so I had 6 ammoniums, but I also wound up with 2 phosphates, which helped to finish balancing out the reaction. Let's look at one more example. Let's take sodium. Let's take sodium sulfate and react that with magnesium hydroxide to make magnesium sulfate plus sodium hydroxide. Okay, this one should have been pretty. It's actually one of the easier ones to do. You should have started out with 2 sodiums, 1 sulfate, 1 magnesium, and 2 hydroxides on the reactant side. And on the product side, you had 1 magnesium, one sulfate, one sodium, and one hydroxide. The only thing that wasn't balanced was the sodium and the hydroxide. So you multiply on the reactant side, you had 2 sodiums, on the product side 1. When you multiply the product side through by 2, you get 2 sodiums, but you also got 2 hydroxides, which balanced out that equation with the 1 coefficient. We will pick up with more difficult balancing on Friday. And again, the homework is 5 questions, but don't, you can do most